Good afternoon, everyone, and welcome to today's Power Hour by NextRev. I'll be conducting today's Power Hour on adding motion to assemblies using Creo Parametric. My name is Jason, and I'll be conducting today's Power Hour. So here's what we'll be discussing today: a little bit about NextRev, talk a little about the process of adding motion to your assemblies. I'll show a demonstration, and then we'll get into some questions later. NextRev is located in the Silicon Valley, specifically in Santa Clara, and we are the largest reseller of PTC products on the West Coast. We provide consulting, training, and technical support around those products for our customers. And we've been doing it. We've got a lot of in-house experience around those products. So if you have any questions, look us up, nextrev.com. So yeah, let's go ahead and jump right into it. So basically, here's your process for building a mechanism. Now you can build mechanisms a couple of different ways. What I'll be showing you is how to use mechanism connections, because that's going to allow you to do some analysis and do some measurements inside of checking range of motion and stuff like that, adding servo motors. And so basically what you're doing is you're building out the assembly first using mechanism connections instead of your typical mate to lines, inserts, coincident constraints, those sorts of things. You're going to avoid those and instead use mechanism constraints instead. We'll verify the mechanism is looking the way we want and working the way we want by dragging it around, and also using a special tool within the mechanism module that allows us to check for any inconsistencies in our mechanism. And then we'll be setting up the model for some analysis and running some measurements against this, maybe to check the maximum distance of the bucket to the rest of our assembly, evaluating those results and deciding then what we want to do with if we need to make any changes. Now, adding the connections to the model is pretty straightforward. It's very similar to any way you've ever assembled components. You're just using mechanism connections instead. You're picking references the same way. It's just you need to know which connections to use to attach the mechanism bodies to each other. The bodies are going to be the different parts. Okay, so here's all of the mechanism connections. The typical ones that you start off with most assemblies, I'd say 90% are going to be the ones at the top here, your rigid, pin, slider, cylinder. And you can see the total degrees of freedom that each one of those allow, essentially. So your pin will allow a spinning rotation. You see that? And zero translation. Sliders allow for the opposite of that. So you have a total degree of freedom of 1, and that degree of freedom is going to be a translation, not a rotation. And then the cylinder will allow for both. And the cylinder is interesting because it's kind of like a pin, but it requires only just one reference, maybe a hole-to-hole mate. And in that case, you're really just trying to tie up the model. It's usually the last constraint that you're adding. And you don't need to control translation or rotation. You'll see very clearly when I add this. Okay, so once you've gotten these mechanism connections in your model, and you've built out your mechanism that you want, you've kind of have a pretty good idea that it's correct, you can actually verify this a couple different ways. You can drag the components around, and you can see the mechanism as it kind of flexes through its range of motion. And you can also use a function inside of mechanism it's called reconnect, and that's going to come back and tell you that your mechanism looks good and it's ready for further work, which would be to do the next step here, which is to add some servo motors. And servo motors are going to drive, say, an animation. We can use snapshots for that, but the servo motors give us more control over how this assembly is going to actually move. We have a lot of different profiles, velocity, acceleration, and position profiles we can use to drive those this assembly using those servo motors. Then we can also define the initial position of our components. It's basically its home position, if you will, when we regenerate the assembly. When we do this, we can also set up and create measures. So again, like if I want to know how far the tip of this bucket is getting from the rest of our assembly, maybe specifically a coordinate system on that assembly, the front of the vehicle, for instance, I can do that very easily by creating a measure. And then after I've created my measure, I run my mechanism through a mechanism analysis. Some of the types you can see here are position and kinematic analysis. I'll be running a position analysis on this assembly. And then we can, after we've run that analysis with our measurements in place, we can play back this assembly, this mechanism assembly, in a few different ways. We can check for interferences. We can show the graphs of the measurement at the same time we're running the analysis, or playing back that analysis. We can even bring in some motion envelopes, which would show the entire range of motion. We can create a model from that so we can see if we have any interferences, and also trace curves on particular portions of them. If I pick a vertex on the front of this front loader, well, that's going to allow me to then show a trace curve through that range of motion for that vertex. Okay, so let's go ahead and start off by creating the mechanism assembly to begin with. And what I'm going to do is open this loader assembly, which already has an assembly component assembled to it. This particular component is just assembled using a default constraint, just what you would normally use. I'm going to go ahead and assemble the next component, which is going to be this arm. This arm then is going to be assembled a different way. We're not going to use these constraints where you see distance, parallel, coincident, and previous to Creo Parametric you'd see mate, align, insert. Those constraints we're going to stay away from here. We're going to actually use mechanism connections instead. And I'll be sticking to the pin, the slider, and the cylinder. And the pin will be used quite often here. So the pin, we'll go ahead and start selecting our references. I'm going to fly out this placement tab just so you can see what's required and the references that I'm adding. So this axis alignment constraint, I need to come in and select a couple of those cylindrical faces, and what that's going to do is just line up that theoretical axis at the center of those. And with the translation, I just want to make it so that this only rotates within this mechanism. So if I say OK to that, and then I use my drag components button, I can then drag that component. And actually, one thing I need to make a change on here. And let's go ahead and select on that translation again because I got the wrong surface. Really don't want this surface here. There we go. Okay, so we have this first component in. We've got a very simple mechanism, but I need to add a few more components to it. So I'm going to go ahead and keep assembling. I'm going to assemble the bucket next. Just drag this over to a new location. Let me just spin this model around so we can get a better look. Okay, again, I'm going to use a pin in this case. It does require two references again, and we're going to select on those two holes to line those up, and then to lock its translation we're going to pick on those two surfaces there. So now we have two components that move around on this mechanism here. And we can use our drag components button to verify that these do indeed move along the path that I want them to. Okay, two more things to add are going to be the pistons, hydraulic pistons that will be driving this geometry ultimately. The piston 1 will go into position from this location to this location. So this is going to be assembled a little bit differently. And so what we want to do is start off with a pin, just like we did with the previous component. And I can pick either one of these cylindrical faces here. That one works. And actually, instead of a coincident constraint, which I think, okay, that works. Okay, so we have the axis alignment. Now we just need to add the translation. If it's in red, that's a required reference. So we're just going to pick this far side surface here, and then the surface here. Now, if I had just left this the way it is, like these other two components, I'm still not connected at this end. So this is the trick behind doing that. What you do is you start off with a new set. You stay within assembling this component. You have the pin connection first, and you just need to add one more. And it's not going to be a pin because I really don't need to control the translation of this model. I already did that in this location here. With this surface here and this far side surface locked to each other, I don't need to control that at this end. So I'm going to use a cylinder instead, which only requires that axis alignment. Alright, so I'm going to select that hole there, and I'll pick on this hole here as well. So now you see it's locked into here, it's also locked into here, and let's go ahead and just verify. Let me just drag on this guy here so we can see. You see, as I drag further down, it actually stops in this location. I'll show you why I'm able to do that. You can see it even has a maximum and a minimum travel distance on it. So let's go look at that real quick, and I'll show you the piston 1 assembly, how that was put together. What that's using is from cylinder, each one of these cylinder parts. If I go and edit definition on that, you'll see that what's been used is a slider. And the slider is a little different because what it does is an axis alignment, just like the cylinder and the pin. But the big difference here is I'm concerned with the rotation of this component in this direction. So I take this surface and this surface, and I basically make them parallel so that this guy doesn't spin around. Okay, now if I just left it this way, this part here could be slid outside of and back and forth within this component, and it would just keep going. If I drag, if I took it and I pulled it all the way out, it would keep going. But what keeps it from doing that is I add one more, which is an optional reference, and that's the translation axis. And here what they've done is they've basically taken this surface and they've just done an offset, right? And so with that offset, you end up with a maximum and a minimum limit. So 80 is the minimum, 425 is the maximum. So it will not go past those two numbers, okay, in either direction. So that's what gives me this limitation in travel. Otherwise, what's going to happen is you're going to get a model that basically will, kind of wrap around and maybe not behave the way you want it to. It can be a little unwieldy and cause you problems down the road. So the next one I'm going to assemble is this piston 2. And here what we'll do is the same exact steps. Pin, select the component reference first, assembly reference. For the translation, this surface here, and then that surface, and then new set, and we'll be adding a cylinder instead of a pin at this end, which allows me to basically just select one reference, and that's going to be the axis to those two there. This one also has a limit on it for travel. So you see there it stops, and also stops in this direction. And I can pick on each one of these, and it looks like I have a pretty usable mechanism for what I want to show today. So I'm gonna stop it there, and then what we'll do is we'll continue over into the mechanism functionality. So far up to this point, Everything I've done you can do with Creo Foundation. Now if I run into with applications under this mechanism application that you see here, this also comes with Foundation. As far as I know, you can do everything that I'm going to be doing today except for a lot of the dynamics options, which requires another module. So the mechanism tool that I just jumped into is going to come with a lot of the newer licensing that PTC puts out. So what I need to do next is then add some servo motors. I want to actually drive this geometry a certain way. So within our pistons, we have that, let's just go into our connections here. And if I look at my joints, you'll see there's a piston 1 and a piston 2. I have that translation axis on each one. That's where I'm going to be placing my servo motors. Okay, so let's go ahead and add the first one. And we're going to pick on that linear axis is pointing me in this direction. So it's going to drive that piston up and down. And for the profile, I want this to be a velocity profile. And I'm going to pick 6 as the amplitude there. And then for the next servo motor, it's going to be the same axis, except for in this case, you see how the arrow is pointing in this direction. I don't want to, from its home position, I don't want to drive it this direction. I actually want to drive it the opposite direction. So I'm going to flip that arrow, and you'll see there's an arrow pointing in the opposite direction, which is the direction I want to go. And it's also going to be a velocity profile. And I want this to be, instead of a constant profile, I want it to be parabolic. And if you hover over these parameters long enough, you'll get the part of the equation you want to enter. So linear coefficient, and then you got the quadratic coefficient. So I'm going to put 0.008 there. Let's try that. Okay. Now the next thing I need to do is, let me just regenerate this to its home positions. And let's go and modify the connections a bit from here, which I can do. I could do it from the rest of the model as well, but here what I want to do is set this to, let's say, 70. Now you see the minimum and the maximum limits here, what I was showing you before in the models, the piston models. So let's see if it'll accept that. Let's go ahead and click on enter. You see how it's telling me wrong current position offset, and that's because it needs to be in the range of 80 and 425, so let's make that 80. That's just letting you know that you made a mistake, which is okay, because maybe I have these pistons set up in a library somewhere, and I just want to know, okay, so well, I want to know for a fact that it's going to limit me on those things. I'll do the same thing for the other piston. I want to change it, basically its home position, to 350. I want it to be as close to its maximum extent as possible. So I'm going to enter that, and we're going to make that the regen value. So whenever I regenerate, it's going to go back to 350. Let me make sure I did that with the other piston. I don't remember if I did or not. Okay, yeah, so the regen value is going to take it to 80. Okay, so let's go ahead and regenerate. Make sure it's going to be in its home position. I'm going to select on this reconnect, and that's what that's going to do, is it's going to allow me to check my assembly for any issues. The mechanism assembly succeeded. Seems like it's pretty happy with that. Let me just drag my assembly to its furthest extents. Okay, and then I'll do the same thing. I just want to make sure that I'm not going to run into any issues when I run the analysis. Now I'm going to regenerate one more time to take it back to its original position. And what we can do is we can go ahead and run an analysis on this just to make sure it's, before we put a measurement in, we can make sure that what we have here is going to work. So let's go start our time from 0 and end our time at 50. So that's going to run a 50-second motion through the entire range of motion here. So we're going to run it. Okay, it seems like it's going to be happy with the way I've set this up. Okay, and we'll go ahead and say OK to that. Now I have an analysis that's been placed in here, and I can play that back anytime I want. So if I wanted to play this back through this interface, you see I can play it forwards, backwards, I can speed it up. I can even capture this to different file types. MPEG, AVIs are probably going to be your best video, and then you can actually change the frame rate to kind of speed that up. Before I finish off here, though, what I want to do is let me just take this back to its home positions, and then what I want to do next is do a measure within my model. That measure is going to be my maximum distance of the end of this bucket to the vehicle itself. So I'll click on the position type, and you can see some of the other types that you can check here. There's quite a few of measurements here you can check. And what I want to do is then pick on the vertex you see there of that bucket. Let me just go to my front view, which is going to give me a nice side profile. The magnitude of that, really I want just the X component of that as it goes through, and I want the maximum distance. So go ahead and apply that. We'll call it max distance. So that's our measurement. Now let's go ahead and run this analysis on that measurement. It's telling me that it may not be up to date, so we'll go ahead and run it through that. It runs it fairly quickly, and it looks like it's not finished. Let's go back, regenerate this to its positions, and we will run the analysis again. Okay, now let's go take a look at let me just regenerate back. Let's take a look at our measurements. Select on that max distance there. Okay, here's our graph. You can see the maximum value that it came up with was 2748. A little change there. And then we'll open this graph up, and you can see the actual graph over time, the distance over time that it gets to, away from that location. Now what we can do here is we can actually play this back at the same time we have the graph up on. Let me just bring up the player here. Okay, there we go. So now let's go ahead and play this. We'll play it at max speed, and as it goes through the graph, and it goes, as it goes through each time slot, it's going to show you the distance that this point is getting away from the vehicle itself. Okay, so it'll keep rotating through that analysis. What I'd like to do next is show a couple more things you can do with this analysis. So for instance, if I wanted to create a trace curve, I have my analysis listed already. You need the analysis first. And so what I want to do is pick on a part, and I would pick a point that I'm going to use for the trace curve, and that's going to be the end of that bucket there. Let's go ahead and preview that. There we go. So we have a curve representing that vertex as it goes through its path of travel. Go back, play our motion. Let me just turn off some of the stuff we're seeing here. Turn that off. And one other thing we can do, we could do quite a few other things, but let me just get out of the mechanism. Go ahead and save and exit that. And I'm going to go over to the Analysis tab, do some additional motion analysis. I have my maximum distance parameter in there. What I'd like to do is create a motion envelope of this bucket. Now let's say I was concerned with where this bucket's going to end up at, and through its range of motion. Let me just make the envelope quality a little better. I'm going to go up to 4. You do have to be careful with this because it can take some time to process. And here what I'm going to do is go ahead and run that analysis. You can see it's going through the graph here. And what this is going to do is create a 3D representation of the motion envelope for the bucket alone in this case. That's the only model that I selected, although I could select the entire armature if I wanted to. Okay, so now our analysis done here. Let me close the graph tool. And you can see that what it's done is it's created a 3D sort of envelope so that any other equipment I had in this location, I could actually see if it was going to pass through that area and maybe have a collision, which is the other thing we can do, is we can check the collision of components. Okay, so that about wraps it up today. I showed you in review the pin, the cylinder, and the pin, the cylinder, and the other constraints. And we also added some servo motors to our assembly. In addition to that, we also ran an analysis. And then we also provided some measurements for that analysis to check through its as it drove that assembly. All right, well, have a good day, and if you have any questions and you need to maybe discuss mechanisms further, I can be reached at this number and email address, and you can also reach us at nextrev.com. Okay, thanks, and join us again for NextRev's Power Hour next week. Thank you.